Hello, guys. So today I want to talk about my master thesis, which is finally done, and it's about knowledge graphs in the age of large language models. So these days, AI is crazy powerful, with the ability to understand natural language more than ever before. The reason they do this is because now they can understand natural language by just reading unstructured text, which is highly abundant in the world. So that means the performance of the model increases with respect to the amount of unstructured text. So, like normal text as we're speaking, as it's written on Wikipedia and social medias. So, it's highly, highly abundant. Whereas before, it was highly dependent on structured text. So, structured text is when someone, for example, puts the labels and says, this is a picture of a cat, someone has to write cat. Then this is a picture of a dog, someone has to write dog. So this type of data is actually not that available because it takes someone to actually do all this work, whereas unstructured text is everywhere. So all these models are incredibly powerful. And what my goal was to do is to try and take a look at how they actually work inside of them. Because even though these models are getting more and more powerful, the explanation that goes with them is not becoming that much more powerful. And on top of this, if we look at a special way, the way I'll be doing in my thesis, to try and have a way to reason with how they're relating with entities and relations, then we can even extract to be more accountable, have better communication with different people, entities, groups, and that's going to be very important. So it's clear that the models are getting huge. Now the smallest models are from 60 million parameters to 175 billion parameters. A parameter is like a number that tells the model, you go here, you go there, more or less. Of course, it's like a part of a function and it's got a formal definition. So these models are getting absolutely ginormous. And my goal was to use these ginormous models to create something that's actually very structured at the end of it. So to extract all relations. So say you're given a text that says, the formal text says, Harry has a son called Jeff and he is married to Celindia, for example. That's a name. And we'd have in this text that Celindia and Harry are both married, so they both cross this relationship. So they have married and then married. And then they both have a sun, so they both have an arrow, which is an edge in graph theory, pointing towards the sun, saying that Harry is the father of, Jeff, and Jeff is the son of Harry, and Jeff is also the son of Celindia. So this is what we're trying to extract. So in this case, it was a family tree extracted. But in many other cases, it can be anything really. So for example, if you'd had another paragraph saying Switzerland has 8 million people and Zurich is the economic capital of Switzerland. So in this case, we'd have Switzerland as a central node and then pointing to 8 million people saying that's its population. And then down here, maybe saying that Zurich is the economic capital. And that would be very nice, right? For accountable reasons and to prosper communication and to make reasoning more effective, more clear-headed. I think that's the main purpose of AI, is to help people. So this is what we did for this thesis. Thank you to Professor Alipi and Professor Mark Carman to have helped me out for this thesis, and Daniela Grattarola for the supervising as well. He was a TA for giving great ideas. And it was quite performed, actually. We achieved some pretty good results. Some maybe like state-of-the-art, although, of course, we'd have to check out bigger models to see if it would be state-of-the-art on every parameter. But at the same time, not only did it perform well, it also has the capability of expanding in many different pathways. So this is going to be important because in the future, maybe we want to have specific ontologies. So ontologies is basically what we allow for these relations to be called. So maybe instead of saying, father, we're only allowed to use the word dad, or things like this in the family tree. So that's pre-specifying an ontology, a set of relations which we are allowed to use. And in this thesis, we showed that it performs pretty well, and maybe that it expand with a set of ontologies. So this means that we can further increase people's understanding in different materials by adapting to their vocabulary. So that was like one of the ideas that came out of the thesis. So say, for example, we have a massive text. It's written in very complicated business German, good luck understanding that. So what we can do is maybe we can build eventually a language model that's adapted to create a knowledge graph that can understand each one of these relations and extract it in maybe simple plain English so that normal people can understand it much better, and it becomes more transparent, communication is better, and it's also accountable. So now no longer is this big model going to be powerful, but it's also going to be accountable because we were able to see how it found that it was this relation and not a relation between the entities. And it provided with some great results. We had to look at it, and some pretty good looking charts you can see here. And we can see that, it performed pretty well. So that's the main idea behind it. Of course, there was like some training, but not only was this also a sort of quantitative problem. So normally you can say, okay, it performed like 70% accuracy. But another thing that was quite powerful that was sort of helped me understand it in the thesis is that there's really no perfect answers in many ways. So say, for example, if we look at an animal and you tell me that's a cat and I tell you that's a dog, one of us is 100% wrong. Whereas in this case, because it's such a complex task, it's got many steps, and at the end it produces something that's got many correct forms. So for example, in the previous part when we talked about the Harry having a son called Jeff, if Jeff referred to Harry as his father or his dad or his parent, all three of these are correct. So it shows that there is no concrete relationship that is 100% right and that the other ones are completely wrong. There's many different forms. So in some ways, this knowledge graph has a vocabulary as well. And this is sort of what I try to illustrate in this little diagram, is that there's like question marks here, that the ideal knowledge graph is not known, and ideal knowledge graph can be different for many use cases. And that was the main idea also behind it, to try and understand how we can deal with these future knowledge graphs. And I think that maybe if we have like a downstream application, say you look at, whenever you Google something like Switzerland, say you Google Switzerland, and you look at the capital and you'll see it's Bern. But you see it in this little box, right? This little box right here. And in this box, you have multiple like little lines, relations, and entities. It's actually extracted from a Google Knowledge Graph. If you look at the world, on average, every person uses it something like 40 times per year. Every person. Like all 7 billion people on average. Not everyone uses Google, of course, but on average, it's been used that much. So this is why I think this technology is that promising, because if it's used like so many times, then basically it's gotta have a massive impact, I think. And so we were talking about how it was quantitatively good. More importantly, it was about the qualitative part. So what's important here is that these knowledge graphs, we can also visualize them, so we can understand what's actually the relationship between all these, not just numbers in a computer, but rather a picture of the ecosystem we're trying to describe using the natural language text. And so I built like a little dashboard using a library, JavaScript library, that helped to visualize it. And yeah, it's all in a GitHub repository, all public, of course. And I think that was the nice part about this thesis as well, is that we understood the power of qualitative analysis in the case of knowledge graphs, of course, to build text. And I think it creates some promising results. It has a future potential, and I want to pursue this project, which is why I also made this video, so I can understand what's going on, and maybe some other people are interested in this thing as well. So with that, I just want to say thank you for listening, and I think it's an exciting time to be alive.